Okay, so from the first video on graphing, we saw to graph a sine or cosine function, you could do it the old archaic way and set up a t-table, pick angle measurements you could look up without a calculator, substitute them in, get out the y values, plot all those points, and graph the sine and cosine curve. But then I finished up the lecture by saying, hey guys, we don't have time for this. What you need to do is memorize what a sine and cosine curve should look like. So let's go and write that here. What I'm about to write is what you should have memorized in your head. When I ask you to graph sine x or cosine x, first of all, the x-axis is labeled in radian measure. In order to label in radian measure, you have to know what angles we were working with. And the 5 angles we saw off the t-table that help us make the pattern of the curves were the quadrantal angles. So what are the quadrantal angles, everybody? That's right. They're 0, 90, 180, 270, 360. So when we graph sine and cosine, that's how we set up our x-axis in radian measure. So we're going to put 0. We're going to put 90, which is pi over 2. 180, which is pi. 270 is 3 pi over 2. And 360 is 2 pi. I'm going to do the same thing down here for cosine. I'm going to put 90 pi over 2, 180 pi, 270, 3 pi over 2, and 362 pi. Okay, I don't care how many spaces you put between those. If you want to put them 1 line apart, 2 lines apart, 3 lines apart, it's up to you, as long as they're spaced out equally. When you graph the sine and cosine according to the t-table, we saw the highest value is always going to be positive 1, and the lowest value is always going to be negative 1. And again, I do not care how much equally spaced is, whether you skip 2 lines, 3 lines, 4 lines. So for cosine, the highest value is 1, the lowest value is negative 1, always. Now, you have got to know the shape of both trig curves for what we're going to do today. If you don't have this memorized, we can't build. You have to know a sine curve always begins at the origin. It goes to its max point 1. It hits the axis. It goes to its midpoint negative 1. And it hits the axis. A sine curve should be an up hump and a down hump. Okay? A cosine curve was different. When you set up the t-table for the cosine curve and plotted all 17 of those points, you should have seen a different pattern. A cosine curve begins at its max. It begins up here at 1. Then it hits the axis. Then it goes as low as it can go. Then it hits the axis, and then it goes back up. To me, a cosine curve is a roller coaster. You climb up the stairs, you're up here at the top of the roller coaster. Here we go down, 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 and then we go back up, up, up. Where I grew up in Six Flags in New Jersey, we had a roller coaster. This is way back now, 80s and 90s, before all these roller coasters, fancy things. It was called Lightning Loops. It started, it went down, went up here, and then it went backwards. And everybody thought that was the greatest thing. So that's what I always think of cosine. Do not make your cosine like straight lines. Don't make it like a V. I got to mark it wrong. It's a curve. That has to be memorized. I will call these guys the parent functions, the original functions. If you know what the original curves look like, then you can graph any sine or cosine curve by hand. Now, what's going to make our lesson today is I'm going to do some transformations. Think about what the word transform means to do, like the Transformers. They means to change. Okay, if you remember the movie Transformers, the robot changed. So it went from a car to a robot or a robot to a car. Transform means to change. These equations, I could put in numbers. I could change the number values, and it will change what this graph looks like. It won't change the whole shape completely, but it will make some types of change. Now, we have to learn 4 different transformations. Okay, 4. Okay? They have names, so we're going to learn some vocabulary. We're going to do 2 of the transformations in this video and some more coming in the next videos. Okay, if you look at y equals sine x and y equals cosine x. Right now in both of these equations, there are numbers. They're just invisible. We know in front of any trig function, it can be connected to the number 1. So there is a 1 in front. That 1 is called the amplitude. Okay? So we're going to use the letter A here to represent the word amplitude. So even though we don't write the 1 in, it's understood to be there. That's 1 times sine x. That's 1 times cosine x. That 1 stands for the word amplitude. If you know anything about sound waves, amplitude is height. Another word for amplitude is height of your curve. If you look, because there's a 1 in front, how high does my sine curve go? It goes as high as positive 1. If you look at cosine, and there's a 1 in front, how high does my cosine curve go? It goes as high as 1. And if they both go as high as 1, they both go as low as negative 1. So that's what that number is going to tell you. The number in front of your sine and cosine that's connected by multiplication is your amplitude. And it's going to tell you how high your curve is going to be. Okay? There's another number in these equations you may not realize. The other number is in front of the angle x. There is a 1 in front of this x, and there's a 1 in front of this x. So there's another 1 that's connected by multiplication. But because that 1 is just connected to the angle, it's not the amplitude. That 1 connected to the angle, which we're abbreviating here with the letter B, is called the frequency. And the word frequency means how frequent does something happen. It means how many. So frequency means how many curves you're going to draw me. If there is a 1 in front here, I expect to see 1 complete sine curve, which is a up hump and a down hump. If there's a 1 in front here, I expect to see 1 complete cosine curve, which is riding the roller coaster, go all the way down, all the way up. What I'm going to do today is change that 1. It may be a 2 or a 3 or a 5 or a half. And that will tell you how many curves I expect you to draw. Okay, so what we're going to learn today to do is by changing the numbers in the equation, we'll change the look of the original parents. You can't do this unless you have memorized what the original sine and cosine curve should look like. So I'm going to leave the originals up here, the parents. And now I'm going to give you a new equation. So I'm going to change some numbers. I'm going to do a transformation. I may change the amplitude. I may change the frequency. And that's going to affect how I draw my graph. All right, so let's go to the notes. Okay, let me get my first equation. All right, so my first equation I want us to graph y equals 3 sine x. First of all, you know you're graphing which trig function? Sine. So our picture is going to look something like this, but not exactly. What I'm a firm believer of is first listing your information. When we graph a trig function, we want to know some things. We want to know the amplitude. We want to know the frequency. Those are our 2 new words. So in this equation, which number is our amplitude? Our amplitude is the number connected by multiplication to the whole function. It is 3. What that's going to tell me is when I draw this sine curve, it's not going to go up 1 down to negative 1. Its height's going to go up to 3 and down to negative 3. The second number I'm seeing here is the frequency. The frequency is the number connected to the angle. Well, there's an invisible 1. So that tells me when I'm done drawing, I should have 1 sine curve we're going to draw. You all with me so far? All right. So we're going to set up our xy axis. You can't graph without setting it up. All right. When you talk about the amplitude, because it's the word height, is height going to affect how you set up the x-axis or the y-axis? Well, height is going up or down, so the amplitude is always the y-axis. So when we set up our y-axis, we want to go as high as 3 and as low as negative 3. So that's what we're looking for. We're making sure that y-axis is set up to be as high as 3 and as low as -3. And our sine curve is going to go up and down in between that. Frequency just means when I'm done drawing, I should see one sine curve. So I should see the up hump and the down hump. Well, I can't graph yet till I put the x-axis labeled, which has got to be in radians. Now, the way we're going to label the x-axis, we're going to need a new word. The new word that we're going to talk about is period. The period is how many degrees it takes to make one complete curve. The period is a cycle. You're going to go around full circle. How many degrees does it take to make a complete sine curve? Well, if you look here, if I ask you what the period is, I'm asking you, how many degrees do you need to make this full curve? Well, if it starts at 0 and it goes to 360, that means our period is 360 degrees. We need 360 degrees to make a complete sine curve. So we have a formula. The formula for period is 360 degrees divided by your frequency, your B number. Okay? In your notes, this is written as y equals A sine BX. Our A is 3 and our B is 1. So that's why for the formula for period they use B. So if we have 300, it takes 360 degrees to make a normal sine curve. We are only drawing one curve here, which means we're still going to need the full 360. Okay? If we need 360 degrees to make a sine curve, we have to plot how many points? 5. To make the sine curve, you need 1, 2, 3, 4, 5 points to do it completely. What you're going to learn how to do is how to mark the x-axis with 5 increments. We know if we need 360 degrees, we're starting at 0 and we're going to 360. Well, you can't put degrees on there. Okay, so I'm going to do it over here. We're starting at 0 degrees, we're going to 360. That would be the first point, the beginning point. That would be the ending point. That's 2 points. Well, then I need to know the point in the middle, because the point in the middle would be here. Well, between 0 and 360, we know halfway is 180. That would be 3 points. Well, then I need to know the point in the middle here. That would be 90. Then I need to know between 180 and 360. That would be 270. So I know if my period for sine is 360 degrees, I'm starting at 0, I'm going to 360. That gives me my beginning point and my ending point, 2 points. But I need 5 points, so I go halfway, that's where the 180 comes from, and I go halfway, that's where the 90. So if you look, we're going up in increments of 90. Now we need to change all these to radians. 0 degrees is 0 radians. Memorize, 90 is pi over 2. 180 is pi. 270 is 3 pi over 2. 360 is 2 pi. There's a pattern here, people. When you write pi over 2, isn't that 1 over 2, 1 pi over 2? Then 180 would be 2 pi over 2. But 2 over 2 would cancel, right? 270 is 3 pi over 2. 360 would be 4 pi over 2. But 4 over 2 would make 2. So these are all going up by halves of pi's, just so you know. And that's how you label your x-axis. These are the 5 radian measures I need to see. Make sure you equally space them. I don't care if you skip 1 line, 2 lines, or 3 lines. So there's pi over 2, pi, 3 pi over 2, 2 pi. That's the most important thing. Even on your homework in MyLS Plus, you have to look at how they labeled the x-axis in radians and the y-axis in numbers to make sure they have the labeling right. Now you know how to draw this. A sine curve begins at the origin, hits its maximum height, which now is 3, goes back to the axis, goes to its lowest point, which now is -3, and goes back to the axis. This graph is a stretched out version of this graph. Now I know it doesn't look like that because I'm doing it by hand, but if I did it on actual graph paper, this would go as high as 3 to be much taller and much longer. So by putting this 3 in front, all I did was take the shape of the curve and stretch it. That's a transformation. Okay? The hardest part's going to be setting up the axis with the radian measure. All right, let's try the next one. The next equation I want you to graph is y equals negative cosine x. Everybody good? So again, you're memorizing y equals a cosine bx. According to that, there's a number in front connected by multiplication, that's your amplitude, and there's a number connected by multiplication to the angle, that's your frequency. By looking here, I've changed my amplitude is the number -1. Now, does that make sense? Can amplitude be negative? What's another word for amplitude? Height. Can height be negative? No. So we say our amplitude is 1. That negative, if your amplitude is negative, it means you're going to graph your graph as a reflection or a mirror image. Okay, and we'll talk about that in a minute. But anytime I ask for amplitude, you always give a positive number because amplitude is height. So I know when I graph this cosine curve, it's going to go as high as 1 and as low as -1. My frequency, my B number, is still 1. So that means I better draw one complete curve. Now, before I draw one complete curve, I need to know how many degrees it's going to take to make that curve. That's the period. You need to know when you graph, before you begin graphing, how many degrees will I need to make the complete curve? Well, that's a straight formula. Period is 360 degrees divided by frequency. So for this trig function, we're going to do 360 divided by 1, which is 360. The period is what's going to help you set up your x-axis in radians. So you're saying if I need 360 degrees to make this cosine curve, I would start at 0 degrees and I'd go to 360. That gives me my beginning point, my ending point. But to cheat, to do a graph of cosine quickly, I only need 1, 2, 3, 4, 5 points. I have the beginning and I have the ending. So I need the point in the middle. Well, halfway would be 180. That's only 3 points. 1, 2, 3. I need 2 more. Halfway would be 90. Halfway would be 270. So I now know when I go to set up my x-axis, these are the 5 angle measurements I must have. But I can't put them in degrees, so I need them in radians. Pi over 2, pi, 3 pi over 2, 2 pi. And 0 degrees is 0 radians. So the period always tells you how to set up the x-axis. The amplitude always tells you how to set up the y-axis. All right, so now we're ready to set up our axes. Amplitude's 1, which means I'm going to go as high as 1 and as low as -1. Make sure you're equally spaced. If you're not, I got to mark you wrong. The period is how you're going to set up the x-axis. We're starting at 0 radians, which is here. I don't care how many lines you skip, whether you skip 2 or 3 or 1, whatever you want, but equally spaced. Here goes 90, 180, 270, 360. Y'all with me? Now you're going to say, well, Miss Black, aren't I just graphing a cosine curve? Isn't graphing this equation exactly like graphing this? Well, no, it doesn't look alike. This starts with a -1. This starts with a +1. So here's where the reflection part comes in. Normally, a cosine curve starts up here at its max, goes all the way down to its min, and then comes back to its max. If it starts out as a negative, it means it's a reflection. When you look at your reflection, don't you get a mirror image? So what's going to happen is this whole graph is going to flip. So instead of this point beginning up at 1, if it reflects across the x-axis, it's going to begin low. So when I graph this curve, this negative in front, if your amplitude is negative, it means it's a reflection. Instead of my cosine curve starting up here at the max, it's going to be here at the min. Then it's going to go from low, it's going to hit the axis, go high, hit the axis, go low again. Remember, it's a curve, not a V. So we curve it. And that is the picture of y equals negative cosine x. It's a reflection. Think about taking this guy and flipping him. That's what happens. Okay? Is everybody all right? All right, let's try another one. Let's go to C. C says graph y equals sine 2x. So again, we changed one number in this equation. It's not sine x, it's sine 2x. That one number affects what the graph's going to look like. It's going to make some kind of transformation. So to graph trig, we need its amplitude. Amplitude is the number in front connected by multiplication. That's 1. That tells us how high and low this sine curve is going to go. This curve is going to go as high as 1, as low as -1. We need to know the frequency. Aha! Is the frequency 1? Nope, there's your B number. The frequency is always connected to the angle by multiplication. The frequency is 2. So that tells me when you're done drawing this, I better have 2 sine curves. So I'm going to have uphill, downhill, uphill, downhill. 2 sine curves. Well, if I'm going to draw 2 sine curves, that's going to change the period. The period is always 360 degrees divided by your frequency. What is your frequency here, guys? 2. If I have 360 degrees and I can divide them among 2 curves, that means each curve is only going to need 180 degrees. So let's think about this. If you only need 180 degrees to make a curve, that means that curve is starting at 0 degrees, going to 180. That's the beginning point. That's the ending point. But how many points do you need to draw a good sine curve? You need 1, 2, 3, 4, 5. So you got to break this up to have 5 angles. So halfway between 0 and 180 would be 90. Halfway between 0 and 90 would be 45. Halfway between 90 and 180 would be 135. That would be the 5 angle measurements on your x-axis. But wait, we're not drawing one curve, we're drawing how many? 2. So this says the first curve begins at 0 and ends at 180. Well, if this is going to be a continuous graph, which means we're going to graph sine, then graph sine, then graph sine, do you agree where the first one ends, the second one's going to begin? So the second curve, so this is for the first curve, these would be the 5 points. For the second curve, you know it would begin at 180, and you know it would end when it's 180 degrees apart. So 180 and another 180 would be 360. It takes 180 degrees to make a sine curve, according to this. The period's 180. I need 180 degrees to make a sine curve. Between 0 and 180 is 180. Between 180 and 360 is 180. But to graph a sine curve, you need 5 points. So we broke this up into 5 points. Now we're going to break this up into 5 points. You're saying, oh, yeah, too much arithmetic. Guys, there's a pattern here. What are we going up in? 45s, right? Well, if this curve is going up in 45s and this second curve is going to follow it, it's also going up in 45s. So this is 180. The next point would be plus 45, 225. Plus 45, 270. Plus 45, 315. So you now know the period is what tells you how to set up the x-axis. The period here is changed. Why did the period change? Because I'm asking you now to draw 2 curves. If I'm asking you to get 2 curves between 0 and 360, that means if there's going to be 2 curves, one curve is only going to need 180 degrees. But to graph that one curve, you always need 5 points if you're going to do it quick. Now, you're going to say, oh my, I got to change all this to radian measure. Yeah, but radian measure is real quick to change to. If you have one of them memorized, you got them all. 0 degrees is 0 radians. This is what you got to have memorized. Radian measure 45 is pi divided by 4. Everybody look at me. That's 1/4. These are all going to go up by 1/4 because they're equally spaced. So if you add another 1/4, this would be 2/4, right? But 2/4 reduces to a half. This would be 3/4. 180 would be 4/4, which is just 1. Okay? 180 is pi. That was 4/4. So 225 is 5/4. 270 would be 6/4, but I can't write 6/4. That's 3/2 when you reduce it. 315 is 7/4. 360 would be 8/4, but 8/4 reduced to 2 pi. So to change all those angles to radian measure is nothing more than understanding fractions. We are all equally spaced. We're all going up by 45 degrees. So if we're going up by 45, we're going up by a pi/4. We keep adding 1/4 to each one. Now we have everything we need to set up our graphs. So we'll draw at x and y axis. The y axis is the easiest to set up. It's the amplitude. What's our amplitude? 1. So I want to go as high as 1 and as low as -1. Do you all agree? It's the radians. We have to put all of these here. They ought to be equally spaced. So here's 0. So now I'm going to have pi/4, pi/2, 3 pi/4, pi. I got the pi already. 5 pi/4, 3 pi/2, 7 pi/4, 2 pi. On graph paper, all of these radians have to be equally spaced. I don't care if you skip one line in between them or 2 lines, they ought to be equally spaced. Now guys, all this is rock and roll time. Plot the points. You know you're going to graph 2 sine curves. So 1, 2. We know the pattern of sine. Sine begins at the origin. It goes up. See, there's a radian here. I got to go up. Then it hits the axis. Then I got to go down, and then I got to hit the axis. So look, between 0 and pi, between 0 and 180, I have 5 points for the first curve. Now I'm going to do the pattern again. I'm at the axis. I go up. I hit the axis. I go down. I hit the axis. So between 180 and 360, there are 5 points. And then I just connect the dots. And I know I'm doing that freehand on the board, so it doesn't look accurate because I'm not equally spaced when I do freehand, but if you did it on graph paper, it would all be equally spaced like you can see in the notes. That's the important part, is by changing this number 2, you changed how many curves you drew, which changed how many points you had to plot. Okay? Is everybody good? All right. Let's try D. D is y equals 4 cosine 1/2 x. All right? We know we're graphing cosine because it has the word cosine. So now the catch is we change the numbers. By changing those numbers, we change what this cosine curve is going to look like. All right, let's go through first. I need my amplitude. What is my A value, everybody? Good, it's 4. A is 4. What does that tell me? Well, the word amplitude means what? Height. So when I draw this cosine curve, it better go high up as 4 and as low as -4. Make sense? The amplitude is always going to tell you how to set up your y-axis. Also in this curve, I see the frequency. What's the frequency, everybody? Well, the number in front of the angle is 1/2, which means we're only going to draw half a curve. So we'll talk about in a minute how many points do you need to plot to draw half a curve. So I don't want to see a full cosine curve. I'm only going to see half of it. By only drawing half a curve, you're changing how many degrees you need. So that's called the period. So the rule is the period is 360 degrees divided by our frequency, which is 1/2. Now, I love you all. You all have calculators. Let's not make a careless arithmetic mistake. 360 divided by 1/2 is not 180. I didn't say divided by 2. I said divided by 1/2. There is no such thing as dividing by 1/2. This really means 360 times the reciprocal 2 over 1, which is 720 degrees. So to graph this cosine curve, because we changed the numbers in the original equation, they're not ones anymore, we changed the period. This says we need 720 degrees to make the full curve. Well, that means if I start at 0, I would need to go to 720. I need 720 degrees to make the full curve. There's your starting point. There's your ending point. That's only 2 points. The point in the middle would be 360. Now you got 3 points. The point in the middle of that would be 180. So we're going up by 180s. So we're going to add 180, we get 180. We add 180, we get 360. So if we add 180, this would be 540. We add 180, we get 720. So when I go to set up the x-axis, it's not our normal 0, 90, 270. It's not that. These are the 5 angle measurements I have to use. Okay, y'all with me? So I'm going to change these to radians. We know 180 is 1 pi. We know 360 is 2 pi. You see the pattern? 1 pi, 2 pi, so 540 is 3 pi. 720 would be 4 pi. 1, 2, 3, 4. Isn't that cool? Now, let's go set up our graph and plot our points. X, Y. Which information, which number here tells us about our y-axis? The amplitude. So we want to mark our amplitude up to 4 and down to -4. Okay? We know frequency means we're going to graph half a curve. Well, if we're going to graph a half a curve, do I need all 5 of these points to plot? Well, let's go over to cosine. If I said only draw half this picture, do you agree to draw only half this picture? You cut it off right here. So when you want to graph half a cosine curve, you only need 1, 2, 3 points. So that means on my x-axis, I only need the first 3 radians. I need 0, pi, and 2 pi. Make sure they're all equally spaced. So now we got, when we graph a cosine curve, does it begin at the origin? No, that's sine. A cosine curve begins up at its highest point, which now is 4. Then it hits the axis, then it goes to its lowest point. And that's all you need. Do not connect these dots and make a line. It is a cosine curve. It's the roller coaster. It looks something like that. So what I want you to do is start appreciating. By changing these numbers, changes what your picture looks like. All right, I think we have one more in the notes. Let's look at one more together. The last example here is y equals -2/3 sine pi x. All right, let's try it again. So which trig function are we graphing? We're graphing sine. So we're going to do some transformations to this parent. All right, what do we first need to know? We need our A, our amplitude. Okay, it doesn't matter whether we're dealing with cosine or sine. Okay, amplitude. Do you say the amplitude is -2/3? Absolutely not. What does the word amplitude mean? It means height. Height is always a positive. We talked about this. When you go to the doctor and stand up tall, your height's a positive number. So I don't care if there's a negative right there. When I ask the amplitude, the number is 2/3. So that means on the y-axis, we're going to go up to 2/3, down to 2/3. Y'all with me? Down to -2/3. Now, you can't just think that negative means nothing. That negative is important. That negative means your picture's going to be a reflection. Okay, so I always write myself a note. When my amplitude has a negative in front of it, it means my picture's going to be a reflection. So we know a sine curve is an up hump and a down hump. Well, that means we're going to go opposite. So this sine curve is going to go down and then up. That's what a reflection means. Okay? From this equation, we should have our frequency number. Now, I know you're not going to like it. The frequency is the number pi. Remember, pi stands for approximately 3.14. Now, you're going to say, oh, Miss Black, do we got to draw 3 1400ths of a curve? No, we'll say we'll draw approximately 3 curves. Okay, we'll estimate. Pi is approximately 3. So that frequency means I want you to draw me 3 curves. Oh no, if I'm drawing 3 curves, then I need to know how many degrees I need for each curve. I need to know the period. If you change the frequency, how many curves you're drawing, you change the period. You're not going to use all 360 degrees to make one curve. The formula is period is 360 degrees divided by frequency. Okay, guys, let's think about this. Can we take 360 degrees and divide it by our frequency pi? No, because this is degrees and pi is in what units? Radians. All right, we'll fix that because we know anything that's written in degrees can be written in radians. So another way to write the formula for period is not using 360 degrees, it's using radians. 360 degrees is how many radians? 2 pi. So we take 2 pi and we divide it by pi, now we get the period, 2. You're going to say, well, that's not an angle measurement. Yes, it is. It's in radian measure. It's a number. You're saying when I go to graph this curve, when I start at 0 radians and I go to 2, the number 2 on the x-axis, I will now make a complete sine curve. But I need 5 points to make a complete sine curve. Here's your beginning, here's your ending. So halfway would be 1, and halfway would be 5/10, or 0.5. So these are going up in increments of half. A half, 1. 1.5, which is 1.5, 2. So these would be, for the first curve, what the x-axis would be labeled. But are we just drawing one curve? You told me how many curves you're drawing. 3. So now the second curve will begin at 2, and how far it will go. Well, if there's 2 units between the beginning and ending of this curve, there's 2 units between the beginning and ending of this. So this would start at 2 and go to 4. Halfway would be 3. Halfway would be 3.5. Halfway would be 4.5. But we're not drawing 2 curves. How many curves are we drawing? Oh, we're drawing 3 curves. So for the third curve, the curve would begin at 4 and end at 6. How do I know that? There's 2 units between it. 4 plus 2 is 6. Halfway would be 5. Halfway would be 5.5. Halfway would be 6.5. Do you see every position is going up by a half? So that is how I'm going to label my x-axis, because I have to draw 3 curves. And each curve takes 2 radians to make completely. So let me get out my marker. Which piece of information labels the y-axis? The amplitude. So my amp is only going up to 2/3. So everybody look at me. Don't mark the first line as 1 and smush it. So I don't care how many lines you skip, mark one of these lines 2/3 and be symmetrical, then mark the line down here as -2/3. Now we're going to label our x-axis. Here's 0, then we're going to go 5/10, 1, 1 and 5/10, 2, 2 and 5/10, 3, 3 and 5/10, 4, 4 and 5/10, 5, 5 and 5/10, 6. I'm ready now to draw 3 complete curves, following the pattern. Okay, when we draw a sine curve, it's sine. Where do we begin at? That's right, the origin. Now, the negative meant we were going to have a reflection. So reflect, instead of going up, it's going to go in the opposite way. It's going to go down. So at 5/10, we're going down. Then we hit the axis. Then we go up. Then we hit the axis. So between 0 and 2, we should draw 1 complete sine curve. Here it comes. Now between 2 and 4, we follow the pattern. That's why it's periodic. So again, we go down. We hit the axis at 3. We go up at 3, 5/10. We hit the axis at 4. Here comes the second sine curve. Between 2 and 4, I should have another complete sine curve. Down hump, up hump. But we're not done. Between 4 and 6, we got to do the pattern again. That's why it's periodic. We go down, we hit the axis, we go up, we hit the axis. That is a transformation of this parent graph sine. the numbers in this equation change what the graph looks like. Now I know what you're thinking. Oh, I'll just go get a graphing calculator. Here's the problem with the graphing calculator. Number one, when you use a graphing calculator to graph trig functions, it does not section off where you begin and end. The graphing calculator is set up to go from negative 360 to positive 360. So if the frequency says here 3, it's not just going to show 3 sine curves. It's going to graph as many curves as it can fit between negative 360 and positive 360. So that's the first problem with the graphing calculator. Secondly, with the graphing calculator, you're not going to be able to see all your angle measurements on the x-axis. It's going to get so smushed together you're not going to be able to see it. So please, 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 it's more important that you understand by changing a number in an equation, you change the way the equation looks. If you have memorized what the originals, the parents, look like, making a transformation is not that hard. So we did 2 transformations today. We learned how to change the height, the amplitude, and we learned how to change out how many curves there are going to be drawn by looking at the frequency. When we come back in the next video, we have 2 more transformations to discuss. Have a good day.